Leecode questions 139 work break. Basically this question want to check if a given string can be break into multiple valid words. So the intuition is pretty simple. We iterate through the strings at each point, such as, for example, given a Leecode. So we start from L, followed by E, E, T, until we find a valid word. Then we split this word, and we only check code later. So once a valid word is being found, we'll split the word and check the subsequent strings, see that can they be forming a valid words. So if we reach the end, then we return true. Otherwise, means that there's no valid words being formed within these given strings, then we return false. So let's start coding. So is valid. Let's build a nested functions. For invalid, we give a word did, word set, and then current start index. So let's build the word set first, because the given word did is in a form of array, so you want to put it in a hash set, which can be done by word set equal to new set word did, and then we simply return is valid as word set, and we start from 0. So starting from 0. Starting from start index. So we iterate from the start index by doing for I equal to start index I is smaller than s dot length I plus plus, right? Check if s start index to I plus 1 is a valid word. So we say temp is equal to s dot slide start index I plus 1 if word set has 10. If this is a valid word, then we will check the subsequent I plus 1 to the end, right? So constant subsequence remaining is valid equal to is valid as word set start index equal to I plus 1, right? So if remaining is valid, then we simply return true. Otherwise, we'll continue in this loop to check for the next character. So when will we want to end this? When we want to end these recursions, we do set a base case. So if the start index is equal to s dot length, means that we are reaching the end. For example, if s equal to Leecode, then we are at I equal to 0, 1, 2, 3, 4, 5, 7, 8, where I equal to 8, which is here. it implies Leecode is valid. Right, so we return true. Otherwise, we'll keep on going. Yeah. So let's check. Use a more complicated test case. False. Why false? Because we are returning an undefined. Means after the whole iterations, we didn't return the value false. So let's do it again. It is taking longer than expected, but anyway, it is able to complete. Yeah, it's taking pretty long. Why? Why is the time limit exceeded? Basically, it's because we have a lot of repetitions while performing is valid. So, for example, we have start checking from a certain start index multiple times because we didn't put a record the status. So let's use a dictionary to record the state. So yeah, dp equal to so false. Yeah. So before we want to iterate from the start index, we will check if we have checked this start index. So if dp dot start index equal to true, right? Then we returns false because it's invalid. Yeah, so how's this dp in and dp start index is true. And here we are done. So for the time complexity analysis, since by using the dp, we only performs the iterations at every start index at most once. So there will be at most n iterations for all start index. So for start index equal to 1, we will have performs a substrings from s equal to 0 to 1, s equal to 0 to 2, s all the way until s equal to 0 to n. So which give us a time complexity of n of 1 plus 1 plus O2 plus O plus plus On is equal to about On power square. So since we have n such start index, we can simply say that the overall time complexity is n times n squared which is bounded by O and the power of Q. And for the space complexity, the DP structure costs about ON, and the substrings cost at most ON. So in the end, it's still ON. And for the stack space, is also at most ON because N is the length of the strings. Yeah, so conclusions times complexity ON power of ON cube space ONs. Yeah, so that's all for our solutions. Yeah, the source code can be referred to the link further below, as well as the other solutions for Leecode questions done in JavaScript. That's all for these sessions.